Find the peak total runoff in cubic feet per second. In this problem, a unit hydrograph for a particular watershed and discharge point is provided. A 3-hour storm event drops 2.5 inches of rain, some of which is absorbed by the soil. To calculate the runoff hydrograph, we'll use the discrete convolution equation, which discretizes the data into equal periods of time, such as 1 hour. In this equation, Q sub n equals the runoff values, which we're trying to calculate, in units of cubic feet per second. P sub m is the average excess precipitation in the watershed, in inches, and the U sub n minus m plus 1 is the unit hydrograph specific to the watershed, in units of cubic feet per second, per inch of excess rainfall. The unit hydrograph for the watershed has been provided in the problem statement. In the excess rainfall is the rainfall which contributes to runoff, which equals the recorded rainfall minus the infiltration. So the excess rainfall equals 0.5 inches, 0.9 inches, and 0.7 inches for hours 1, 2, and 3. With all values of P and U determined, the hydrograph is set up. In the convolution equation, n refers to the time period, and little m refers to the hour of rainfall. Therefore, it may be easier to equate each cell in the hydrograph to the product of a P and U value. For example, the first column, first row, refers to n equals 1, m equals 1. And using the convolution equation, this cell would be equal to P1 times U1. Using this formula, we can assign a product to the remaining cells, based on the row n and the column m. Solving for runoff from the first hour, Q sub 1, we notice there is no U0 or U minus 1 term, since the second and third hour of rainfall cannot contribute to the first hour of runoff. So the second and third terms of the equation equal 0, and the runoff for the first hour is simply 0.5 inches of excess rainfall times 5 cubic feet per second per excess inch of rainfall, which equals 2.5 cubic feet per second. This equation is repeated for the second hour, and we notice the third term cancels out of the equation again. The values of U and P are plugged in, and the second hour equals 14.5 cubic feet per second. Runoff from the third hour of the storm is calculated the same way, and equals 44 cubic feet per second. The last 5 hours of calculations are completed, and we're left with a runoff hydrograph, resulting from the excess precipitation of the storm. To calculate the total runoff, we need to add the base flow of 15 cubic feet per second to the runoff hydrograph we just computed. Since the problem asks to find the peak total runoff, we identify this value as 150.5 cubic feet per second. When reviewing the possible solutions, the answer is B.